Hello and welcome to your algebra class. Chapter 1, Section 1 starts off on variables and expressions, and what we're really reviewing is how the basics of algebra work. And of course we're going to start with our vocabulary. You are familiar with these words, you've heard them before, but if you don't remember them, please consider writing these down. Most vocabulary I'm going to ask you to write down, and in fact I prefer that you have a vocabulary section in your notebook. While these are review, I will expect you to know them. So, a variable is a letter or a symbol that's used to represent a value that can change. This is X in every single algebra problem you've ever seen. Then we have constants, a value that does not change, also known as a number. Numerical expressions contain both numbers, which we call constants, and operations, where algebraic expressions contain variables, constants, and operations. So as soon as you stick a letter in one of these math sentences, then it's called an algebraic expression. So the first thing they want to remind you about is translating math into words. And they've got all of these little words that I need you to be able to recognize in a word problem so that you understand that, oh, when they use one of these words, they're talking about adding or subtracting, and there's words for multiplying and dividing as well. But the more familiar you get with these words, the easier those word problems are going to be. So we're going to start with the examples that they give in the book. And the first set of examples that they talk about is give two ways to write each expression. And this is changing math into words. And you can see all the examples that they give in example 1. And this is just one I'm going to ask you to go through because it's the very first section of the very first chapter. And I'm assuming you know how to do this. If this is something, going through the example 1, if this is something that you don't know how to do, then let's sit down and talk. But example 2 is all about translating words from words to algebra. And they do give some examples. So we're going to work a similar problem together. Fred runs 0.4 miles in 1 minute. Write an expression for the number of miles he runs in m minutes. So an expression does not mean we're going to solve it. There's no equal sign. An expression is just using constants, which are numbers, and variables, which are random letters. So we're going to take our 0.4 miles. He runs 0.4 miles in 1 minute, because 0.4 times 1 is 0.4. But how many will he run in m minutes? So we're going to multiply 0.4 times m. And you can write it 0.4 times m if you'd like, but this is really the best algebraic way, and some people will argue the 0 in front. I don't care. We've also got Sally has 1 more pencil than Peter, who has X number of pencils. How many pencils does Sally have? Well, if Peter has X pencils and Sally has more, then Sally has X plus 1. More is one of those words that is used to describe adding. If this was a less than problem, then what I want to show you is that in subtraction, just like division, order matters. If Sally has 1 pencil less than Peter, then you have to start with how many Peter has and subtract 1 to get Sally's. Whereas when we're adding, it could be X plus 1, it could be 1 plus X. These are the same problem, and order doesn't matter, and both are correct. The word problem they have on page 8, in example 4, breaks it down for you in words. This is what it looks like when they put it in a paragraph. They have approximately 14 20-ounce plastic drinks bottles that must be recycled to produce 1 square foot of carpet. If you can rewrite that into something that you can understand, it really should look like this. 14 bottles makes 1 square foot of carpet. And suddenly all of these words, it's obvious how all of these words aren't necessary. 20-ounce plastic drink bottles is all just, they're bottles, and you don't need the rest of it. And the fact that they give you numbers in a word problem that you don't use can be frustrating. So if you can start by translating it, you're better off. A asks to write an expression for the number of bottles needed to make C square feet of carpet. Well, if 14 bottles is 1 square foot of carpet, then how many bottles does it take to make C? So I'm going to take my 14 for 1, and I'm going to multiply it by C, square feet of carpet, and that's going to give me the number of bottles I need. So if I need 2 square feet of carpet, I'm going to multiply 14 by 2, and if I need 15 square foot of carpet, I'm going to multiply 14 by 15. The second part asks you to find the number of bottles needed to make 14, 120, and 224 square feet of carpet. Now, they're making this chart for you, and I am going to ask you, even though this seems like a whole lot of work for no reason, algebra is going to ask you to get familiar with and be able to work with linear functions. And linear functions are often set up like this, where instead of C and 14C, this is X and Y. And we come up with values for things in exactly this same kind of format, and we use them to graph lines. So I'm gonna ask you to make a silly little chart, and it's really quick, and you're gonna use 3 lines, and if this is 40, then this is going to be 14 times 40, and there's your answer. If you can get used to this format, the sooner you get used to it, the easier learning algebra is going to be for us. So on the bottom of check it out here, they ask you to do exactly the same thing, but with different numbers in a different scenario. Please pause the video and try this to make sure that you can do this. So when you do problem number 4, it asks you to break down what it is that we're doing. We have 1 sweater made of 63 bottles, taking all the rest of the information out. When it asks us how many bottles it'll take to do S sweaters, it's going to take us 63 times S sweaters. That's the number that we're looking for 4A. And then in 4B, they're looking for us to fill out a chart. And they want to know how many it's going to take for 12 sweaters, 25 sweaters, and 50 sweaters. So we're going to take each of these numbers and multiply it by 63, because each of these represent S. So this is actually 63 times S. So here's our S, and here's our 63, because in multiplication order doesn't matter. And then you get out your calculator and you do, and you end up with 756 and 1575 and 3150. If this doesn't make sense, put a hazard sign by it so that you remember to ask me about it tomorrow. Homework for this section is number 25 through 31B plus number 36. We're going to do sections 1-2 and 1-3 also tonight, so there aren't that many problems each, but hopefully they're review enough that you can do them quickly.